Hi, and welcome back to Dr. Karen's Math Hacks. I was working with my students on ratio problems, and there was one mixed in that wasn't a ratio problem, but it really looked like it should be. Instead, it's what I call a men working problem. That's a typical 6 men work 5 hours, so how long does it take 10 men type of question. That type of problem looks like it should be a ratio problem, but it's not. And there's a way we can tell whether it's a ratio problem or not. So let's take a look. Okay, when we're scaling something up or down, we usually have the case where we have two situations, one where we know everything and one where we don't. Uh, so the example I used last week was a building with a shadow and a stop on a street sign with a shadow. All right, we knew how high the street sign was and how big the shadow was, and we knew how big that the building shadow was, and we didn't know how big this was. Now we can use ratios to do this because it makes sense that when buildings get taller, their shadows get longer, right? And we just use this to scale it. But if you have a situation like you have 6 men working 5 days, how many men would you need to get it done in 2 days? Right? That looks like you should be able to set it up as a ratio with men and days. 6 men, 5 days. How many men for 2 days, right? This is 12 divided by 5, which is 2 2/5. Okay? But does it make any sense that fewer men will get things done in a short amount of time? No, it really doesn't. Okay? When we have a ratio, we're actually drawing a line on an axis here. This is the height axis, and this is the shadow axis. All right? The stop signs is a point here, and these will always go through the center. Okay? So all we're doing when we're solving a ratio problem is saying, okay, we've got this line, so if the shadow is 20 feet, what is the height? Okay? So the key thing to do when you're looking for whether the problem is a ratio problem or not is to ask if it makes sense if both numbers are zero. If you have a problem like you've got a train that is going 25 miles an hour and it's traveling for 3 hours, so how fast does it have to go to get there in 2 hours? Okay? This looks like a ratio problem, but it's not, because if we put zeros in there, it doesn't make any sense. Okay? Okay, if we have 0 hours and 0 miles per hour, how are we getting there? We're not moving. Okay? That tells you that it is a men working problem, which means that we have to multiply the numbers rather than setting up as a ratio. So if you have 25 miles per hour times 3 hours equals 2 hours times our speed. So then we have x equals 75 over 2, which is 37.5 miles per hour. So now it makes sense because the larger speed will get you there faster. Okay? A slower speed would not get you there faster, and that's what a ratio would give you. So if we were looking at 6 men working 5 hours, and we want to know how many men it would take to get it done in 3 hours, We're multiplying because having fewer men does not get it done faster. Okay? If you're putting zeros in, that doesn't work. Doesn't make sense. You know, if you got 6 guys painting and it takes 5 days, by getting 0 guys, does it make it instantaneous? No. So, what you need to do to find out whether it is a men working problem where you're multiplying or a ratio problem where you're setting up the ratios is to put zeros in and see if it makes sense. Because a ratio will always be able to go through 0, where a men working problem will be ridiculous. Okay? If you found this video useful, please consider liking, sharing, or subscribing. In addition, if you want this information in a way that you can have for your very own, check out my book on Amazon. See the link below.